The country is expecting what I call the 10% mantra to rehappen in India. Now, the real question is it possible for it to rehappen? And even if it does, how long will it last? Um, Actually, I consider sustainable development, which people are talking along with growth, as an oxymoron. Uh, I believe that either you can have sustainability or you can have growth, or you can have development. Now, what is development? Development, whatever you like to say, is basically a change, and that change happens with the expenditure of a certain amount of energy. And so, if you want, for example, 100 smart cities, which is now being talked about in India, unfortunately, nobody sits and does a computation as to how much energy will it take and how much is it going to cost. And when we computed it, we found that it is going to take basically 600 million tons of oil equivalent. That's two-thirds of India's annual energy expenditure, costing approximately 35 lakh crores, which is double the uh, budget, union budget for 2014-15. Now, where is India going to get this kind of energy or money from? Let's leave aside money, because money I can print notes. The question is, can I print that energy? The answer is no. Now, energy growth has been somewhere in the region of about a little under, sometimes a little over 6% per annum. Now, at that rate, if I were to say that let us have smart cities, and I say that we want, I defray the cost of these smart cities over 10 years, then the energy growth will have to jump to close to something like about 9.5% or 10%. How is India going to do it? Because India's got huge coal reserves, but today we're importing 20% of our coal. We're importing 71% of our oil. We're importing 29% of our gas, and that's where we are. So we're competing with China in certain places to buy oil wells and coal mines and different continents. And in some places, in fact, we are even joining up with China against other bidders to find that energy. And as energy grows scarce, in fact, it's going to become more and more difficult for India to do this. Now, if you upscale this whole logic to the world as a whole, the question is that are we in a position to grow from the current almost 13 gigatons of oil equivalent that we are using, not counting another 6 gigatons of what I call photosynthetic energy. If I don't count that and count only what is called commercial, TPES, total primary energy supply, we have been growing anywhere like about 2.3% per annum. Now, we have just 100 years of coal left, we have another 40 years of oil left, and we have about 55 years of gas left at current extraction levels. Oil is getting over. We now know about that quite well. The Americans have tried to shift the bell curve, and they've probably managed to do a little bit of it, because essentially by digging oil shale and shale gas, they've shifted the bell curve, which is famously called Hubbard's curve, by maybe about 20 years or so. Otherwise, if they'd not done that, actually peak oil probably is already here. They've shifted it, but even their protagonists agree that 20 years down, that the oil production curve is going to go down by about 2040 or so, or 2035 or thereabouts approximately. Now, oil gone, gas gone, coal. You try to replace oil and gas with coal, you're going to increase your problems of carbon dioxide emissions, because basically per joule you put out 2 times the amount of carbon dioxide as you would in the case of oil, and much more than 2 times in the case of gas. So if you try to replace these things with coal, you have problems. If you try, the other problem is nuclear. There is only enough ore for approximately 80 to 90 years or so, given the current 400 odd reactors or so. Now, if you want to shift to fast breeders, that technology has had huge problems, and those countries which have built these reactors have, by and large, every country has shut them down, barring one country. If you want to talk about, for example, fusion technology, the question is how do you contain the fusion reaction that happens at 5,500 degrees Celsius approximately. There's no material that we know on Earth which can contain this. Only plasma can, and they're trying to crack this for now years. They still are quite far away from coming anywhere to convincing even themselves that actually it can be done. Now, what is an obvious answer to this? The obvious answer to this whole thing is to basically power down. And so you have to define something called what is sustainable extraction of energy from the earth. And our computations show that sustainable energy extraction is roughly 60% less than what we are extracting today. Now, that we are already in overshoot, energy excess extraction is now fairly well accepted, even in the commercial circles and things of this sort. How much do you have to power down by is the question. Now, I have said 60%. There are others, including scientists who've written papers who, in fact, go up to 90%. There are various reasons that's going to take long to discuss. Okay. So, but just reduction by itself is not possible. Why did we go into overshoot? Because some people decided that they wanted to extract more and more and more. Now, this is what I call the class that basically owns private property. Right through slavery, feudalism, and capitalism, essentially it is their drive to accumulate more, which has made them extract more and more energy. Now, the question is that if they cannot really extract more energy, then what do? They will then basically essentially do one or two things. One is that they will shrink capitalism to areas where this extraction is possible. The other areas will be left to themselves to fend. It's like, jiska lathi uska bhais is what is going to happen in these areas. Lawlessness will take over, disease and basically deprivation is going to take over in those areas. And finally, even in the selected areas where capitalism has shrunk, energy starts failing, then there is going to be a civilizational collapse of the same sort that we have seen probably a dozen times earlier, right from the Mayans to the Polynesians to the Romans to the Indus Valley civilizations essentially have collapsed because of energy shortages. And these energy shortages were creation of these civilizations themselves. Either there has been overreach, like in the case of the Romans, or there has been over extraction of energy, as has happened in the Mayan civilization or the Polynesian civilization. But we don't learn from history. We want to do it all over again. We still believe that growth is possible. My point is very simple. Please do the math. When you do the math, you find that essentially the equations don't work out. They don't equate. So you want so much, it's not available. If it's not available, then you have to reduce. If you don't reduce, you are going to collapse. Yeah, you see, it's like what one economist said, that what is economics? Economics is ultimately, all about extracting energy with the least use of energy to extract it. That has been converted actually into money terms. A equation of value and the unit of energy, joule, is what needs to be done in this whole thing, which is what it is in reality. This equation works up to a point where you say that value is basically in a society where you can talk about human beings in terms of inputs and outputs, in terms of the throughputs that happen in the economy. Problem is that economists, by and large, until ecological economics came onto the scene, did not consider two things. that there is a finite limit to the energy that Earth can give us, which is sustainable. And the other is that there is a finite limit to the wastes that we produce, which the Earth can neutralize. And we have overshot these two. And so what is happening is, on the energy side, already we can see the wear and tear in terms of replacement of entire forests with let us say palm oil plantations in places. On the waste side, you can see that regionally there is wear and tear. Again, on the energy side, not only do you see this, on the input side, not only do you see this wear and tear regionally, you can see that today the Earth is actually groaning at a global level, because that is what carbon dioxide is all about. No matter where you release this carbon dioxide, it is going to make Earth groan all over the place. We are putting out more than double the amount of carbon dioxide than what can be sequestered back today. And that is a huge problem. And this problem is essentially because those who privatized natural resources, particularly energy, want to extract more, because that is where the surplus comes from. What is that surplus? Essentially, if I put in 1 joule of energy, then in the case of coal, I can get back anything like 30 to 80 joules. With time, this return reduces. So the more I extract, the more surplus I make. It's like, I like to give this example of an auto wala. There was a girl who once wanted to come and meet me. She was coming to my city for the first time. And then when she called me from downstairs, I went down, and just as the auto was going away, I asked her, how much did you pay? She said 100 rupees. I said, good Lord, the meter should have shown about 30 rupees. Now, the auto wala, to actually maximize his profit, what does he do? He expends more energy to do it, and he converts it into money terms. So, if you want to make more profit, you have to have more of the economy. Okay, you have to do more economic activity. Okay, the same thing in a sense works on the question of energy. If I want to extract more surplus energy, then I have to extract and expend more energy. It's as simple as that. Now, that is the system that obviously has led us to this whole problem, that by privatizing energy, we have come to an extraction point which is not only inequitable, but which is unsustainable. So the whole question of inequity is the flip side coin of sustainability. You cannot solve these two problems independent of one another. And that is what, in fact, many economists have attempted doing, and that is exactly why it has failed so far. So the question of sustainability and equity have to be taken up together. I don't know what is green energy. Is there such a thing called green energy? I mean, could you please tell me what is green energy? I understand these things in terms of energy inputs and outputs. Is there such a thing called green energy? I don't know of one. Now, if you by green energy mean wind energy and solar energy and things of this sort, by no stretch of imagination are they green in that sense. So you want to call it green, go ahead, please. For me, essentially, these are energies which are low density energies, and therefore cannot give you the same kind of surplus which fossil fuels can give you. And the problem with these energies is, besides intermittence and so on and so forth, the technologies that are there to extract these energies basically are still in the process of being, let us say, improved and so on and so forth. But if you look at, say, wind energy and wind turbines and so on, we've hit a point where we can say that it has come to a fairly mature stage. The problem is that if I want to, say, do 1,000 megawatts of energy with coal, I require only 1 square kilometer or 2 square kilometers, including the ash ponds. If I want to do it with wind, it is anywhere from 200 to about 1,000 or 1,200 square kilometers or so. If I want to do it with biofuels or bioenergy, biomass, I require something like about 6,000, 8,000 square kilometers or so, approximately. If I want to do it with solar, which is not the best suited technology for pushing it into grid power, except, small panels. You can't talk about doing 1,000 megawatts and so on with solar, and which is why wind, in fact, you can today talk in terms of so many gigawatts having been installed in a country, but in solar we are very far away from that as yet at this point of time. Today solar technology technologies which can tap solar energy can do very small amounts. Now, all these put together, in fact, are giving us only 0.3% of the total global energy consumption today. That is wind, solar, geothermal, etc., etc., etc. Hydro is giving us only 2%, whereas fossil fuels is giving us close on 80%. It's actually 79% globally. Nuclear is giving us 6%. So if you talk in terms of fossils and nuclear, it's 85% already. The remaining 10% is biomass, and the etc. etc.s are the remaining. So the question is, what really is the future? And when we looked at wind a little more carefully and looked at what are the sites it can be done, there are a limited number of sites. Leave aside the intermittence problem and things of the sort. Finally, we said that look, all this talk about solar energy giving us 2000 terawatts and so on is not what is called technically feasible. What is deployable actually is 1 terawatt. Okay. Now people are talking of all kinds of other solutions like put up tap wind in what is called the upper air. How are you going to get to the upper air to tap it? Number one. Number two, the upper air issue is also an issue of does it have a sufficient momentum? It might have speed. That doesn't mean it has momentum. And it is momentum that will give energy, because in wind there is something called a power law. So you have to have both the mass and the velocity. It's not there. The other problem that recently there are two other issues people are talking about. One is that if you extract that energy out of the wind, will the wind have enough energy, in fact, to do what it is meant to do? That is basically do atmospheric circulation. So if you extract that energy, what happens to the clouds? Is one issue. That will it start changing the whole pattern of precipitation, particularly, for example, the South Asian monsoon, which is so important, and it's the most grandest part of the whole the atmospheric circulation. The second thing is that you put these wind farms all over the place, and recently an American wind generator was fined $8,000 because about some 4 or 8 very rare species of eagles got stuck in the wind turbines and died. So what happens to these things? And then the third question that came up in Australia is, if you put up the wind farms, where will the kangaroos jump around? And so on. So there are a lot of unresolved issues with respect to these things, which are both technical as well as ecological. And the jury is still not out on these. So they're really not an alternative. The other issue is that once you change your energy source, it's not just the source. There's a huge infrastructure that has been created for extracting and delivering energy from fossil fuels. Now you try to extract energy out of different systems, you'll have to change your infrastructure. That cost is now actually not been factored in, and it's not too easy to actually factor in that cost, because people are still attempting to grapple with how much energy is available with the alternatives and how much of it is really deployable. That's the term that's used, deployable energy. My own belief is that the solution lies in powering down to 40% of what we are using today and in equity. If we don't do equity, then basically we'll get back into the same rut that we got into. If some people start owning energy resources privately, then essentially they will want to extract more and more surplus, and therefore we'll again go back into an overshoot. And this has happened in the past. But essentially we need to learn from the past, which unfortunately we're not doing. You see, one of the issues that economists, until Rogan came along, did not understand is that basically the economy is a heat engine and therefore has to follow thermodynamic laws. Efficiency can actually give you maybe about 15% more energy. Given the same input, your output can increase maybe 15% or so. Beyond that 15% or 20% increase in the output energy, you're not going to get more, because there are thermodynamic limits to what you can do with a fixed amount of energy input. This is one issue that you can't use efficiency. This is what America, in fact, is right now concentrating on, improving efficiency to extract more energy from the same input energy. In fact, they've said, okay, let's forget all the other solutions, let's implement this. And that's what they're doing systematically. That's not going to solve the problem, because essentially you are still in a cycle where people want to extract more and more. And the minute people want to extract more and more, they will then go and dig out oil shales and oil gases, and there are other people who are actually the impacted people who feel those minor tremors or whose groundwater is being polluted are going to resist. And of course, oil shale is nowhere close to, the cost of it is 30% more than conventional oil. And in terms of the amount of water resource that you require is massive. You've taken that water and you pollute it and you push it back into the ground, and so it's going to pollute, and many places it's going to pollute the groundwater, and the community is going to then yell, saying this is not what we asked for. Worse than oil shale, its EROEI is even less than oil shales. Its EROEI is very close to between, I think, 1 and 5. It's probably closer to about 2 to 3 or so. At least with oil shales, you can say that it's closer to maybe 7 or 8 or something of that sort. Tar sands is, as a substance which pollutes, it's even worse. And moreover, there are fractions of what you put out in chemicals out there which are toxic. Absolutely. I have no doubt about it. And not only that, it's creating conflict, because, for example, the oil shale in India, there are significant geological formations. Unfortunately, those formations are on the India-Pakistan border. And the whole conflict on Sir Creek, which is between India and Pakistan, it belongs to me, or the other guy says it belongs to me, is all about oil shale, is all about energy. I would say that it's a disappointment, not just in terms of, let us say, the quantities, but it's a disappointment also because whatever was there was not extracted for reasons of pricing. And basically Reliance apparently is being fined for that. Now, of course, they will resist the fining. But they didn't up the production because they felt that it was economically not viable for them to take that gas out and oil out and sell it and so on. I do believe that there is some amount of gas and oil there. So why is it if Reliance, basically if ONGC is still getting gas out of that area, that Reliance is not doing it? I would comment in this sense that I think the political leadership and some of the scientific leadership in India is aware of this problem. The leadership is in denial about this issue because I know for a fact that they are aware. I have had personal discussions with people at fairly high levels on this issue. Some of them do know about it. They're helpless in that sense because of the growth mantra that we have imbued at the political level, at the bureaucratic level, and then taken it to the masses and told them no politician can go to the people and say that, listen, we need to tighten our belt. Every politician has to say, I will give you free power or something, and compete with the next politician. If this guy is giving X, then the next fellow will have to give 1.1x or 1.2x, freebies or in terms of development promises and things of this sort. So there is a mix. I would say that there are a large mass of people who are unaware of this. So the question is that we need to make people aware so that there is an open debate. You see, basically there are three very critical questions we need to ask and answer. The first two deal with the quantities, and the last, of course, doesn't deal with quantities, it deals with how we do it. The first question is, how much can we take from nature without disturbing nature? Or what is really the sustainable extraction that we can do from nature? And this has to be defined both globally and locally. It's a little easier to do it globally. It's far more difficult to do it locally. because you have to figure out, what is the meaning of disturbance to nature. You have to define it. And that's what is a big problem, and you have to quantify that, the numbers, that is. The second question basically is, where do we get this energy from? What are the sources of energy, where we can get this kind of quantity of energy? Then again, we have to look in terms of areas, quantities, and so on. And to me, it appears that it makes a lot more sense actually to take people to where energy is rather than bring energy to where people are, because that's a far more expensive proposition as compared to taking people to where energy is. For example, if you have energy in high energy yielding lands, then obviously that is what historically has happened. They've gone and settled there. So if we want to do that, then quite obviously we have to move towards soft borders and finally no borders at all. We have to move towards a society which is far more accepting of other cultures, etc. The third question is, how do we distribute energy? What is the basis for distribution of energy? And essentially, if we say that the basis has to be equity, then the question comes up as to, is it equity between the current generation, or equity between generations, or equity between species? And if we then talk about equity between generations, we have to quantify how much can we take, how much can the next generation take, and so on and so forth. And it's not just energy, because there are about 30 other raw materials which are going to exhaust within the next 30 to 40 years. So what is the extraction rate of not just energy, but what is the extraction rate of other non-renewable materials? That is something else that we need to look at very seriously. Then if you talk about energy between species, the question comes up, while in the first two we can talk about value of energy and things of this sort. When you talk about equity between species, and that if we are part of nature, and we assume that let us be equitable with other species, then theory of value fails. What do we replace it with? So basically, I feel that this is going to require an enormous amount of discussion, not between academics and academicians and so on. This requires discussion between people themselves. After all, we didn't have academicians and researchers and so on when people decided to use a certain kind of a method for barter. It was decided on a certain basis, which is common sense. Now, we need to do that. And so we get into the whole issue of ethics in this business of what is the basis of valuing energy, or anything for that matter of fact, if we say that let us be equitable with other species. Another very tricky question comes into play, for which I have a very partial answer, but we need a lot more debate on that. Not only is the history of nature and human society basically the history of energy and energy conversion, which means that the history that I studied in school, which is of kings and queens and some villains and conquerors and so on, basically not the way I look anymore at history. I look at the kings and queens as bit players in the whole grand narrative of energy conversion, which is what has influenced the most both nature of continents coming together and splitting apart in a 400 million year cycle because of energy conversion, or for that matter of fact, surpluses being created by human societies all the way from hunter-gatherers up to today's societies. Without that surplus energy, in fact, no so-called development would have happened. Sorry, I forgot the point I was trying to make. The basic story of history is the history of the creation of energy conversion knowledge. Because while other species basically extract energy with their fangs and claws, we really extract energy using our brains. And therefore, we are able to use our brains to figure out with what we now call science as to how energy can be extracted. Then we use engineering to figure out, the art and the, science of really how to do this whole thing. So essentially what it has done is it has made humans actually work against the rest of nature, because by expending this kind of energy, we are doing something called negative entropy. Whereas by creating order, which is what the rest of nature has done, because it takes only, other species take only as much energy as what they require and no more than what they require, whereas we keep on expanding the amount of our energy drawals. Other species basically do negative entropy, whereas we do entropy. And today, the entropy that we create, in fact, has surpassed the negative entropy to a point where drawals, in fact, are things that are making Mother Earth groan. And it is like in Hindi, there is a saying, or in any language, there is a saying that apne pair par kulhad marna. The very thing that gives you your basic sustenance is something that we are hacking away. So we need to change that completely, and I believe that the only way to change it is just like we have gone into things like mimicking nature in different dimensions of science. We need to mimic nature even in terms of energy. And so what nature does, or rather the biotic part of nature, is it does risk minimization, whereas what we have done is gain maximization. We need to go back to risk minimization if we want to survive. I believe that remaining in the paradigm of gain maximization is actually basically taking us towards collapse.